Hi, this is a quick update on the machining that's been done on the block for my engine build. In an earlier video, I detailed measuring various parts of the engine block. One of those that I measured was the main bearing diameter, which should be 65 to 65.019 millimeters. When I was measuring those, I found that one of them was definitely oversized. Another one was a bit marginal and there was a bit of variation between them. So I decided to have them machined out to the next size up, which is 65.25 to 65.269 millimeters. Now, when this is done, basically the two case halves have to be bolted together as they are shown here. Now, in terms of the bolts that go through them, there are obviously 6 cylinders on the engine. Now, each cylinder has 4 bolts around it, as you can see here. So that gives a total of 7 main bearings. So there's going to be a total of 2 bolts for each one, so 14 bolts. Now, as you can see here, we've got 10 bolts here. Then there's a nut in there. A bolt goes through there, and on this side of the block there's another 2 bolts there. So those are the total of the bolts that go through. Now, in terms of the case alignment, the cases have to be aligned so that this hole is round. You don't want the two halves offset. Normally when the engine goes together with a crank in it, there's a nose bearing in here, it's known as bearing number 8, which sits in this hole here, and the crankshaft spins inside it, and that basically aligns the two case halves from this side. On the other side, at this end, there's 2 dowels, one each side of here, so that's what aligns this side. So when you want to machine the crankcase, put all of these bolts in, and then they're torqued up in sequence, starting from the middle and working out. So these are done as 11 and 12 in torque sequence, and then the 2 from the back around here are done as 13 and 14. They're torqued up to 50 Newton meters, and then when those are all done, the bolts around the circumference are all put in and torqued up to 25 Newton meters. Now, when I wanted this block machining, I took it to an engineering place. I took the 2 case halves plus all the nuts and bolts with these through bolts, along with the printed instructions from Porsche about how to measure it, how to assemble it. They put the 2 block halves together. Then after some time they contacted me and said, I'm afraid we can't do the job because although we'll be able to bore it out and hone it, we don't have the facilities to measure accurately through the depth needed. As you can see through there, we've obviously got a total of 8 sections to measure. But they told me they knew somewhere that could. So I said to them, great, send it there. So that was done. I then collected the block after it had been machined, and then I used my dial bore gauge, shown here, to check all of the measurements, and they were all within spec. Fantastic. Then I thought, right, take it apart, clean it up. Now, in terms of taking it apart, I put it on the engine stand and then started undoing the bolts, which again start from the middle and work out. I could feel there was good force required to undo all of these because they're torqued up to 50 Newton meters, except when I got to the last 2, the 2 that go through here, which basically clamp up this end one here. They were just sort of finger tight. So I thought, that's not good. I better clamp it all up again and recheck. So I torqued them all up properly, again starting from the center, working out. After doing that, checked all the measurements, and this one here was undersized by about 0.05 millimeters, because once obviously it was machined when it wasn't clamped up properly. So I contacted the people who did the machining for me, and they said, we might be able to do something, but because of how it's honed, they have to hone over the whole length of the block. And they said if they do that, it might take the other ones out and make them oversized, which would then ruin the block. So that wasn't a possibility. So I had contacted another company I use called Specialist Engineering and explained the problem to them, and they came up with a solution to fix it. Now, when you want to machine these blocks, what you can't do is just stand it on its end, measure that hole and then machine through it, because you don't know when it clamps up whether it clamps up evenly on both sides. It might be that one side moves in more than the other. So the solution that they came up with for how to do it was to machine up 2 steel bars. So these are the 2 steel bars here. Now the diameter on these, there's a step in the middle. So this section here is 65.25 millimeters, so minus 4 microns, 4 microns under that, so 65.246. So that will fit through the bearings which are cut to the correct size. And then this one here is the same but for the original bearing size, so just under 65 millimeters. Then the idea with these steel bars is that this bar would fit in through there and then would poke out of the other end. Then you put the other bar in from this end, so you've got the 2 small diameters poking out each side of the block. Then you can bolt the block down onto a machine table and then you can clock it up. So I'm just going to cut away now to some photos showing the actual process. So in this first photo you can see the engine block clamped down onto the machine bed. So this was a bit of a job to get the spacers and blocks right. So once that's done, then the 2 bars are fitted into the machine, and then using a dial indicator it's aligned so that it's correctly aligned vertically and horizontally, so we know that it's dead straight. Then the bed of the machine is rotated 90 degrees, and then by using a touch probe the machine is then set up so that it's centered in the middle of the hole. So it's actually being centered on the bar that's running through the center. Once that's done, the 2 bars are then removed from the block and then the hole can be machined. So the bearing hole was taken out to the correct size, and as well as the first one being taken out, the next one down, it was slightly tight in that, because obviously bolting up the one next to it affected it slightly, so that was taken out very slightly as well. So it was taking out around about, I was told it ended up taking about a similar amount off each side, so it was around about 0.02 millimeters off each side, a couple of hundredths of a millimeter. So not a lot, but enough to make it that the bearings would be tight. And then once that's done, then the bars then fit correctly through the block. So if we back to the block, if you have a look in here, you can see that some marker was put on the block before it was machined. So you can see on the area where the join is, there's no mark. It's not been machined on there, it's just had material taken off around here. So basically across this face. I've since checked it again, and now, as far as I can tell, the bearings holes on either side are to within around about a couple of microns are the same size at each end. So a huge thank you to the guys at Specialist Engineering. That's Keith, Robin and Jay, who did the work for me, got it all sorted out. And now I can strip the block and start to check bearing clearances.